We all know what velocity is, don't we? Look at me, I'm moving forward and backward on this swing. So I have a velocity. Hang on. Aren't I at rest? I'm sitting firmly on the seat. So with respect to the seat, I'm at rest. With respect to the ground, I move. So clearly, velocity depends on the reference. Velocity is a vector. I can have a forward velocity or I can have a backward velocity. The magnitude of that vector we call speed. If I could go faster and faster and faster. Although physics tells us that with respect to any reference system, there is a maximum speed. That's the speed of light in vacuum. That cannot be exceeded. That's due to relativity. But that's not what we talk about here. We are firmly in our world, in our reality, and that's really well described with classical physics. And in classical physics, we do not have to worry about relativistic effects. Formally, velocity is a vector in a coordinate system. For example, in this Cartesian coordinate system. It has three components, Vx, Vy, and Vz, that are aligned with the unit vectors of the coordinate systems, as indicated here I, j, and k. Algebraically, the velocity vector can be written in different ways. One can draw a little arrow above the V symbol, a tilde underneath. One can use a bold letter, and that is done in many textbooks. And of course, one can write the velocity vector in its components, in matrix form, from top to bottom, or in a row with commas separating the three components. All of those notations mean the same thing. Velocity is a vector. Generally, velocity has three components: an upward, a forward and a sideward component, an x, y and a z component. Velocity is a three-dimensional vector. In one dimension, it's either forward or backward. How do we determine velocity if, let's say, we know two positions of a point mass of an object? The position r1, as defined in a Cartesian coordinate system, and the position r2, as defined in a Cartesian coordinate system. In between, the object follows a trajectory, and the displacement between r1 and r2 is given by the vector delta r. Delta r is the difference of r2 and r1. If we divide delta r by the time that has passed, delta t, we obtain what's known as average velocity, the average velocity vector. This is not very useful because it depends on our choice of delta t. How much better would it be if we could define velocity for a particular point in space and a particular point in time? That is possible using calculus. By taking the limit for delta t going to 0 of the average velocity, we obtain the instantaneous velocity v of t. When we speak of velocity in physics, we mean this instantaneous velocity.